All right, so here's what we're going to do. We are going to be graphing sines, cosines, and tangents, and secants, and cosecants, and cotangents. That's this whole next section, 5.4, 5.6, 5, 5.6, 5.7, 5.8. All right, and so today is your first intro of it, which is fine. It's just different, all right? But you can do this. You know how to find the sine values on the unit circle, right? If I give you an angle, can you find the sine value? Yes, you can, absolutely. And that's all that this is based on, okay? So here I have my table. Y is equal to the sine of x. So if x is at angle 0, we're just going to fill in our table. At the angle of 0, what is the sine? 0, because sine is y, cosine's x, right? Okay. At pi over 2, what is sine? 1. At pi, what is sine? At 3 pi over 2, what is the sine? At 2 pi, what is the sine? Brew. Okay, so what we have created are what I call the key points. All right, so my x and my y, that first point is 0, 0, so here's a point. My next key point, if I read down the table, is pi over 2, 1. Then it goes pi, 0, 3 pi over 2, negative 1, and 2 pi, 0. Can we live with that? Nothing too bad, right? So when it comes to graphing, what the heck is that going to look like? So we draw these things right here. It's going to look like this. Because if I look at my x coordinates, I'm starting at 0. I don't need the negative side of my table. So I'm going to start at 0. My next x coordinate is at pi over 2. The next one is at pi, then 3 pi over 2, and then at 2 pi. And then let's look at the y values. What's the highest y value? Positive 1. What's the lowest y value? Negative 1. Okay, so now we just literally plot the points that we just found as we read around our unit circle. Okay, so we have 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. Now if I connect the dots, it makes this little shape. Now, we know from coterminal angles, I could keep adding revolutions, couldn't I? And I would end up with the same sine values over and over and over, wouldn't I? Because it's very repetitive. That's why you see the arrows on the end. This is cyclical. That's what they call it. It just cycles through. Cycles through. If you've been in physics and you see frequency waves, they cycle through, right? And you look for what we call one period of the cycle. Y'all heard that before? Physics? One period of the cycle. So when we talk about period, we talk about how long on the x-axis did it take to get from the starting position back to the starting position and hit all the y values in between. So what is that distance? It's 2 pi. Okay? So we call that the period of the cycle, 2 pi. So far, so good? Another feature of this graph that you will have to talk about is what we call the amplitude. You heard about that in physics too? Amplitude is what? Do you remember? It's the height of the curve, right? Okay, height is like a distance. So here's what we're talking about. We're talking about this distance right here. That's a height of 1, isn't it? Is that the same as this going down? Yes. It's still a height of 1. So my amplitude is 1. Okie dokie. Can we live with that? Good. All right. That's sine. That's what sine looks like. Now, let's do the same exact process, but this time with cosine. Boop. All right, cosine, what am I looking for? The x values. Thank you so much. All right, so where x is 0, what is the cosine at 0? Pi over 2, what's cosine? At pi, what's cosine? 3 pi over 2? 2 pi? 1. So we're going to graph the same thing. If we list our points from our table, the first point is at 0, 1. So that's up here. The next point is at pi over 2, 0. Next one is pi negative 1. And then 3 pi over 2, back at 0. And at 2 pi, we're back up to 1. If I connect my dots, what'd you say, Jazzy? It looks like a V, doesn't it? Starts at 1, ends at 1. Starts at 1, ends at 1. Again, if I kept making revolutions around my unit circle, evaluating cosine values, wouldn't I keep getting the same thing over and over and over? All right, so this is cyclical as well. What we've graphed is one period of cosine. So, what is the distance of the period? How long does it take to get through the whole cycle?
2 pi.
Good, 2 pi. And again, amplitude is the distance from the midline. Whether it's up or down, that distance will be the same. How far up does it go from the midline? 1, good. Y'all act like this is so easy. Is it so easy? So far so good at least?
Yes.
Not so bad? All right, good. So that is where we came from. We took the unit circle and we found points and we graphed them, right? Yes, amplitude will always be positive because it's a distance. Exactly. Good question. Okay, so here's some definitions for you. Amplitude of y equals a sine of x. That a is just could be any number. And y equals a sine or cosine of x represents half the distance between the max and the min values of the function and is given by the amplitude of absolute value of a. So when you're looking at an equation, you're looking at the coefficient in front of either sine or cosine. That is going to tell you the distance from the midline up. Okay, the way it's phrased right here, it's half the distance from the min and the max, right? If I look at the distance from the minimum all the way to the maximum, that would be 2. Half of that is 1. So there's more than one way you can define it, but it's always positive, and it's always the distance from the midline. Okay? So one of your jobs is going to be able to just look at an equation and without graphing it, tell me what the amplitude is. So what you're looking for, or looking at in the equation, I should say, is this coefficient in front of whatever trig function is there. That is the indicator of the amplitude. Now, your job is to take the absolute value of that value. What does absolute value mean? It's positive, right? Absolute value translates any number into a distance. Distance can't be negative. So it just makes whatever it is positive if it's not. So like on number 1, if I want the amplitude of this sine function, I take that 4 and I take the absolute value of 4 and I get, or negative 4 I should say, and it becomes 4. My amplitude is 4. Number 2, what's my amplitude? 2/3. Number 3, what's my amplitude? 5. And number 4, what's my amplitude? 7. So far, so good? Here's the thing. As we graph these things, you're going to look, these equations for sine and cosine are going to get a little more complex. Right now, all we're concerned about is this value out front, that coefficient A out there. okay? Happens to stand for amplitude. Does it always work that well? No. But that number in the front is going to tell you your amplitude. Got it? All right. Now, period is the horizontal distance from the beginning to the end of one cycle, like we looked at on the graph. Period has to do with this number right here with your x, b. All right? It's given by 2 pi over whatever that b value is. Because we saw in the graph the generic sine function takes all the way to 2 pi. So if there's a value besides a 1 that's connected to your x in your equation, it's going to change the period. That means it's going to, like an accordion, take that sine, either shrink it down or stretch it out. Okay? So we got to do just a little bit of math here. So I'm looking at the b values. There's a b value here, there's a b value there, there's a b value right there. Right? So let's look at this. Okay, so what would my period be for number 1? Well, I would do 2 pi over the b value is a 2, and that reduces it to a period of pi. All right, now look at number 2. What's the b value here? Good. B is 1/2. So I have to do 2 pi over 1/2. Keep change flip, right? If I keep change flip, what does this become? That means it's 4 pi. So that's taking that sine curve, stretching it way out. This one's shrinking it down to that entire curve to happen by pi. This one's stretching it all the way to 4 pi. What about number 3 here? It would be 2 pi over 3. That's my period. What about number 4? 2 pi over 2 over 5. So I have to keep change flip. That becomes what? 10 pi over 2, which is 5 pi, right? 5 pi. So there's a little arithmetic potentially. Not a ton, just a little. Can we handle amplitude and period? Yeah? Okay, good. Now, transforming. This is where we're headed. I'm not expecting you to get this all right now, but this is where your video is going to pick up tonight, is when you see, bless you. When you see any equation for sine, and you're asked to graph it, you're going to see all kinds of stuff going on. Now, A we already talked about. That affects the amplitude, right? The height of our peak, or troughs they call it. B affects the period. C and D we have not talked about before. However, you know this from Algebra 2. Let me take you back to Algebra 2 for a minute. If I gave you this, and I said x minus 4, what is that minus 4 doing to the graph? Remember, it's opposite logic, right? Because it's happening to x. So we move it to the right. Guess what this does right in here? Same exact thing. It's a left and right transforming, okay? We'll deal with that in a couple days. Then if I added onto this equation, if I said plus 6, what is that plus 6 doing? What do you think D does? Up or down? Exactly, up or down. So you're using knowledge you had in Algebra 2. Guess what? You're using it in trig. It's the same. The newest features are amplitude and period because it wasn't cyclical, and now it is. All right, so when it comes down to it, what's going to happen is you're going to be referring back to our key points up here that we used. These 5 key points. Now, because I'm just so dang nice, I'm not going to make you memorize those. I'm going to give you a note card, and you're going to write these down, and then you have to be able to utilize them correctly to find the new points of the equation. Fair enough? But when I refer to key points, this is what I'm talking about, these right here. So these are my key points for sine. These are my key points for cosine. Yeah? And then we're going to use this little doodad right here to help us find our new values. Don't let it scare you right now. All you're going to have to do is look at the equation given and identify what is the B value, the C value, the A, and the D. And I will show you how to do that in the videos to come. All right? So your first one really is just where the heck did this graph come from? What is amplitude? What is period? And how do I find it from the equation? Can we handle that? All right. That's your introduction to graphing. As we move through the other trig functions, you can imagine it's going to go a little faster because you kind of have a framework for it. Maybe, possibly. Okay.